Hello, we are Cloud Gateway team, and our goal is to allow administrator of cloud to scale their application for peak demand time via a burst to a public cloud. As we make this in a secure way, we try to make VMs in hybrid cloud work like they are in the same subnet. So our motivation is to expand resources for peak workload times, and we allow VMs in a hybrid cloud to work like they are in the same subnet. We try to do this in a secure way. Okay, Cloud Gateway VM approach is to facilitate network expansion. For example, you are the administrator of a private cloud and you need more resources, so you want to rent some resources from a public cloud. So you use our cloud gateway and you can expand your resources. There are other side goals also. One of them is that this connection should be a secure connection. The other is we should have a connection flow between our private cloud and our public cloud. And the last one is port forwarding to redirect traffic flow to certain VMs. Chanli will talk about the issue part.
Okay, so VPN is an existing solution for this, but there is some problem that VPN cannot solve. For example, in this graph, we have in the left side is the public cloud. We have two machines with IP address 10.0.125 and 10.0.123. And in the right side is the private cloud. We have two machines with IP address 10.0.122 and 10.0.124. In this case, the traditional VPN cannot work here because we are now able to divide these two group of machine into a perfect subnet CIDR block. So to solve this problem, we use two VCG with an IPsec VPN tunnel between them to secure all the packets, and then we will use IP table to redirect all the packets to allow this kind of fragmented IP address, and also other side goals. Now I will explain how it works. So in this case, at first we will deploy a total different subnet in public cloud and the private cloud. In private cloud, the subnet CIDR block is 10.0.0/16, and in public cloud, the subnet CIDR block is 10.1.0.0/16. And to enable the machine in the public cloud works like they are in the subnet in the private cloud, we will add some destination net rules in the IP tables. Below, in the bottom corner of this cloud rectangle is the destination net rule we add. For example, we have a rule that if a packet, the destination of packet is 10.0.123, it will be redirected to a new destination 10.1.0.123. So here, if the machine want to communicate with the machine 10.0.123, the packet will reach the VCG first, and then VCG will modify the destination of that package to 10.1.0.123 as in the rule, and then the packet will be redirected through the tunnel and reach the other side VCG, and then will be direct to the virtual machine it should be directed to. Also, if the virtual machine in the public cloud want to communicate with the machine with address 10.0.123, which it assumes that this machine is in the private cloud, it just send a packet with address 10.0.123, and then when the packet reach the VCG, the destination of that package will be modified to 10.1.0.123, and then will be redirected to the machine in the public cloud. Also, we enable the internet connection, port forwarding by using IP tables port forwarding rules. Like if an user in the internet, he want to connect to the to some machine via certain ports like port 80. So he just connect to the VCG with the VCG's public IP address, and then it will connect to the port 80, and then the VCG will redirect all the traffic to port 80 to the 10.1.0.123 to a new machine. To enable such mechanism, we need to have two VCG in both cloud with VPN tunnel setting up, and also we need to synchronize the IP table rules between two VCG to enable this network deployment. Doing this manually, doing this manually is very time wasting. So we also made some automation scripts using CloudFormation and AWS Python SDK called Bottle3 to facilitate deploying VPC network and VCG on the cloud. Also, we build web services in the VCG so that the user can control the IP tables in two VCG in the same machine. We also made a web interface for the administrator or DevOps to modify the IP table rules. We think this is cool because first we solve the problem that traditional VPN cannot solve, which is the fragmentary IP address in the different clouds. Also, this will allow machine to work in standalone IP address, and the script we built allow DevOps to deploy their VCG very fast. The pre-deployment only takes 7 minutes. After the pre-deployment, every time the DevOps want to expand their network into the cloud, it only takes 1.5 minutes to boot up the machine and run the network properly. In this project, we learn how to work with our team, work with each other. We learn to use the Amazon API, OpenStack API. We learn about the VPN connection, the difference between IPsec and OpenVPN. And also we learn, while building this project, we learn a lot of network troubleshooting skills, and also a very general software development skills. So our future goal is to allow DevOps to export and importing VM between private cloud and public clouds, which means they can transfer their virtual machine working in OpenStack, for example, to AWS. Also, we need to fix bugs in our code. So after this, we are going to present you a demo of our project. And the first demo is how we deploy the network and the VCG. So as you see, we have this is our network setting in the private cloud. We have a machine here. We have a machine as a VCG connected to the network 10.1.1.0.24, and we have two machines as workers connected to the network 192.168.1.0/24. And now we are logging into the machine. Here is a demo of our config file. We allow user to configure their network in the config.yaml file, which allow them to design the VPC CIDR block and in the public cloud, and also the VCG IP, private IP. And then they can run the deploy script to deploy the VPC and the network in the public cloud. This process will take about 7 minutes. Okay, what these scripts do is at first this script will deploy a VPC and a network in the public cloud, and then it will boot up the machine, install all the required software in that machine. After the machine is initialized, it will create a snapshot and then create an AMI image from the machine, and then it will delete the machine and leave the AMI image in the VPC. So we will have we will have an image of the virtual cloud gateway. Anytime we want to put up a virtual cloud gateway, we can just put up from this image. So now we are trying to deploy the VCG. Okay. So deploying the VCG, to deploy the VCG, we will first allow an elastic IP to the VCG using Boto3, and then we boot up the VCG using CloudFormation, which will take about a minute. After the VCG is booting up, we will have it will try to establish an IPsec tunnel between it and the VCG in the private cloud. We can see the tunnel is established right here, and then we can ping the VCG. Yes. And now we are going to demo how our web interface works to redirect the packet. Now we are trying to run the web server, the server on the private cloud VCG, and we can connect to the server and load in the page. We have a worker machine working in the public cloud with private IP address 10.0.1.2.3.5. We want this machine to work like it's working under the IP address 192.168.1.2.3.5. So we just add the destination net rule here. This rule will redirect all the package to this IP address, to the IP address that it should be directed to. After that, we log into the worker machine in the private cloud side, and then we try to ping this IP address. As you can see, the ping work, which means the packet is directed from the private cloud to the public cloud. Also, our web interface will allow the DevOps to enable or disable internet connection of the cloud gateway. For example, now the worker cannot ping Google because the internet connection is disabled. So we can enable this by clicking on the internet button. And then the machine is able to reach Google now. Also, we'll have a port forwarding feature here, which we already demoed in our demo 5. So that's it. That's our project.